welcome to Major League. We play in Chicago, Toronto, London, Kaunas, and Vilnius. And this is our company values. Yeah, so I think that's the slide you haven't seen. That's where all those cities came from. So we're from the Bridge Group, and this is our company values. See, we have a bunch of them. I like the last one, having fun. And test automation is a lot about having fun. One of the reasons is because most likely if somebody is bored in his workplace, good chance that is because he's doing some repetitive work. He's doing something twice, something that he's already have done. And that's natural because you should feel bored when you're doing repetitive work because there is no value in doing repetitive work. Every time when you do something, second time, the same thing, that's when you can automate it. That's when you don't need to do that, actually. And that's how you not get stuck and bored in routine and same things over and over again. So today I will try to convince you, because as the title said of our presentation, it's zero from hero, so we're assuming some of you aren't even convinced that you need automation in the first place, so I will try to do that. So let me start with this story. One day, where the email comes to our team mailbox from the security guy, and this security guy, he has a beard, and you know when somebody has beard, he understands security. and yeah, that's true. And in this email, he says, well, guys, fun times are over. jQuery that we're using in our product for a long time, it has a security issue, and we must upgrade it to new version. Well, does that sound scary or not? Well, there's nothing strange about upgrading library or software. It happens every day in IT life. But the thing is that after such major upgrade, you have to retest everything. Every part, every feature, every corner of your product. And I think you're already managing all those regression plans, all those manual regression plans that you will need to go through, all those thousands of steps that you know by heart already. And you need to repeat them once more again, so you could say that, okay, this upgrade was fine, no new issues here. I think you imagine all that manual work that you need to do to assure that upgrade went fine. Well, actually, I hope you don't need to do that, and you don't even imagine that, because you have automated tests to do that for you. So this is first reason that I wanted to put in the list on why you probably need test automation. It's because manual testing is boring. Maybe not everybody agrees with me on this one, but I think most of you do. But there are more reasons. Let me ask you this question. How often do you release your product? Who releases at least once every year? Can you raise your hands? Okay, I see a lot of you. How about every month? Every week? What about every day? Okay, there's still some, but not so many. You can release every day if you have continuous integration. And continuous integration who is not familiar is basically it's such a pipeline where every time that you push, the developer pushes some code, some new functionality, some machine runs builds, installs, and runs all the tests, all the automated tests on that software, and it will, at the end, it will either flash a green light or a red light. And you always want it to be green light. Mostly because, well, green light is beautiful. it makes you feel safe. It's like everything is all right in life. And also we don't want to miss that adrenaline rush that you get when you see red light. That red light will wake you up. It will make you think fast, act fast. And it's not always pleasant experience, but it's needed experience. So the second reason for why you need test automation is it allows you to have complete continuous integration setup. Let's go further. I want to tell another story about a bug, about the life of bug, all the cycle that he runs through. So at the beginning, there is a developer, and he produces bugs, like a bunch of them. You can see that little bugs under the developer in the slide. Next thing that developer will do, he will probably execute unit tests on the product. And that will catch some bugs, and there will be left little bit less of them. Next, you want code reviews to happen. It's very important that another developer, another person would look through same code with fresh eyes to see everything that he might not think about and stuff like that. That would be very important, and it will catch some more bugs. A little less bugs will be remaining in the software. When you have API tests, if you have backend application, you're dependent on it working right, and you need those API tests to make sure of that. This will probably catch some more of the bugs. And then you have UI automated tests, the tests we're talking about here today. And it's quite important place in this whole cycle, because it will catch some more bugs, and after user interface automation tests, there will be manual testing. And manual tester is especially important because nobody can beat that intuition that the tester have, that experience he has over the years, that feeling of the product that he might use to test it. But after manual tester, the next person who finds the bug will be user. And that one remaining bug, probably he won't like it. So the thing is that manual testing is the last line of defense, and you want to leave as little bugs as possible for a manual tester to find. So that would be the next reason for test automation. You want to support the last line of defense. Let's try to think some more reasons. Well, the one I already talked about is it's fun. It usually makes a manual tester more motivated and less bored and more happy in his workplace. And you want to be happy in your workplace, right? So I think this reason alone would be enough, and that's, by the way, picture from our company value. So, sorry, company party. So you can say that we're really embracing our values, and having fun is one of them. The last reason I have today is about personal growth. These days, especially in IT world, you have to always keep ahead, and learn all the new skills that can help you, and programming is crucial skill. There's no arguing against it, I think. And what test automation allows is to manual testers to learn this new skill that will help them in their career, that will help them to that will allow them to have a safe place in the market. So it allows testers to learn programming. That is all the reasons I have. I believe most of you are convinced already, but the decision to start test automation is just a beginning. A long road of hard work awaits ahead of you, and if it's the first time that you go that road, you would benefit from some help, from some inside knowledge, from to use some experience of others who has already gone through that road. And I would like to ask my colleague Paulius to talk about our test automation framework and the lessons that we learned while building it. Thank you.
Hello there. So I would like to begin with a story of how we actually got here. So it all started 1.5 years ago when it was decided that from now on we're starting to work with new front-end architecture. This new front-end architecture is based on custom components. These custom components will be built and then reused in all of our products. So you could imagine this like an assembly line. Initially, all of these components needed for the end products will be created. Then they will be brought to this assembly line, and then in a very rapid process, they will be assembled. And to make things interesting, all of these end products that will be created very fastly, all of them has to be covered by automated tests. So your framework has to support this crazy development rate. And at that point, we already had a framework. It was a legacy framework that we got it from the company that we were working with, and it was based on robot framework. But the problem is that it had a lot of issues. First was the duplicated code. There was incredible amount of it. For some reasons, people, when they needed to add something, they just simply went there and created their own implementations. Even though they're similar or exact ones already there, for some reason they created their own. There were thousands of tests there, and maintainability was very difficult. There were a lot of abstraction layers, a lot of retries that were just simply implemented there. And in some cases, I truly believe that these tests pretty much brute forced to succeed. It retried so many times that it actually, in the end, succeeded. So it was messed up situation. Also, our developers did not know that programming language. So if we needed some kind of help, we could only rely on our other test engineers. And in some cases, that might be okay. But that might be the reason why first two issues actually existed. So at that point, we had a decision to make. As initially, we have a time frame until all of these components are built. How do we spend that time? Are we improving this framework? Don't get me wrong, it was working. It was like a garage. You could actually build end products there, though the rate at which you could do that was not sufficient for our project. So what do? We try to fix this one or start completely fresh. And as our title implies, we started fresh. So after this 1.5 years, I truly believe that we succeeded. Not only that our framework supports the new stuff that has that crazy rapid development process, but all of this legacy stuff, those thousands of tests are already migrated to the new framework and it's tested there. And the old framework is getting deprecated. So it actually works. And we had a lot of fun doing so. And fun, as Vaidas emphasized this a lot of times, is what you're actually aiming for. So we really did have fun building it. Now, when you're starting fresh, when you're starting from zero, there's a lot of risks. And risk management is very important. So what you want to do is to keep those risks as low as possible. So what we decided that we've chosen C# and nUnit, two technologies that are already used by our programmers, and we chosen them. So in that way, we could, if there is some additional information that we actually don't know how to solve some kind of problems, there's some possibilities that might end up in dead ends and stuff like that, you can always ask your developers how would they do it? How can this be done better? And this is very important. And also what you get is, as all of your features have to be covered by automated tests, that means that if you fell short-handed and you cannot implement those automated tests by yourself, there's always developers that are capable of jumping in and applying those, writing those tests. And it actually happens. And as we needed to interact with web elements, we've chosen Selenium. It's mainstream these days. Everyone's using it. Everyone has knowledge of it. There's a huge community and a lot of examples. So by choosing these free technologies led to, we actually never regretted about it. All of them works as intended and we actually like it. Now, everything is made of components these days, from the simplest products to most complex ones. As a manufacturer, when you're trying to produce as many of these products in a very fast pace, you will always try to reuse as many of these components between those products as you can. As an end user, when you're using such products, if you know how to interact with one of these components, for example, what properties and methods are applicable to this component, as this component will be used throughout of the products, same properties and methods will be applicable to all of them. So, for example, if you're an end user in a vehicle that has a steering wheel, you can apply methods to it like turn the wheel left, turn the wheel right, honk the horn. If the same steering wheel is reused in multiple vehicles, in multiple projects, same methods are applicable to it. And so from the manufacturer side, they want to reuse the components. From the end user side, you can reuse the interaction with these components. So it's kind of a win-win. Both of the sides get some kind of reusability. And that is what we actually used in our framework, because this can be applied to the components, to the web components. So our developers initially created all of these custom components that all of them were used to create all of our end products. What we did then is implement them in our framework. We implemented all of these custom components in our framework with the ability to select them. The selectors could not have any context in which the elements are placed. They had to be totally generic. Developers created them totally generic. We had to maintain that. So what we did is implement the ability to select them. And also, like my previous example, we implemented the interactions with it. As test automation is all about simulating how the end user will interact with web page, we wanted to add all of the possible properties and methods that the end user would actually do to the components to these custom components. So this was applied to all of them, from the simplest buttons to fields to custom components that were made of other components. Like this one, all of our project was built from those, and the reusability was huge. But then we had to make the interaction as easy as possible. And there was an issue because Selenium web element is a totally generic component. You can apply all properties and methods to it. So you could, if you have a button, you can send text to it. That will cause an exception, and we don't want that. It leads to the place when the user that is writing the tests has to know what he can and cannot do. So if you want the interaction to be as easy as possible, what we decided is all of this interaction with web elements are hidden inside of these custom components, and we only exposed properties and methods that are applicable to them. So when the user is writing automated tests and he interacts with these components, he only sees properties and methods that are applicable to them. And as these are totally custom, you can name them properly, so when you're actually looking at the test, it's very human readable. And that is what we want. The human readability and stuff like that implies that you can actually write the test faster. But if you have totally generic components, all of them, how can you be sure that when you find this component, that you're actually interacting with the correct one, the one that you actually need? And for that, we used context. So a simple task. You have to go and knock on the totally generic door that has number 10 sign on it. It might be very easy. If there's a door in front of you, you go knock on it and it's the correct one, then yeah, the task is very simple. But if you think about this worldwide, there's probably millions of such doors, of millions of such generic doors with number 10 signs on it. So how can you be sure when you're standing in front of the door, so when you knock it, then someone's angry screaming at you is not popping out, and there's actually the door that you actually need? So by that, we implemented the context that shrinks down in the scope in which you're searching for the door. So by knowing information like the country, the city, street, and house will lead you to the final place where you actually will be searching for this door. And this was applied to our web elements. So for instance, we have totally generic component, confirmation modal, that's made of, there's confirmation modal component, and inside of it, there's 3 containers, the header, content, and actions. Inside of the actions container, there's 2 buttons. And these 2 buttons are totally generic and only differ by the labels. And then if you have the same task that you have to go and click on the button with label no on it. What it means that by shrinking down the context, by selecting this modal inside of the DOM, and then selecting the actions container, will lead you to those 2 buttons. Not all of the possible buttons that are in the DOM, that might be thousands of them, but the exact 2. So all you have to do is select the one with the label no on it. But this leads to huge selector strings that are very difficult to maintain. So what we did is we implemented the ability in our custom components to pass 2 mandatory properties in their constructor that when you're instantiating these components, you have to pass in the context in which these elements are placed, and also some unique properties or attributes that actually allows you to differentiate when multiple are used in the same context, like these buttons, the labels. So by this, all of these huge selectors are not just simple strings. They are formed dynamically by just instantiating these components one after another in the same way that actually the DOM is made, and just passing in the context between them. Now, when you have these components, the main building blocks of your test done, all you have to do is write the test then. So when writing these tests, you just simply need to navigate to some component that you're actually testing, interact with it, with the stuff that we already mentioned, and then assert if it's okay or not. So writing of the tests becomes very simple. They're very intuitive, and everyone pretty much can do it. But under the hood, in the framework, there is a lot of complexity there. And it's awesome because some people might not be that much into programming, and they will be able to write the tests as you only expose properties and methods that are public. And all of this hardcore stuff might be hidden inside the framework. And that is what we want. We want tests to be as easy as simple as possible, but the framework most likely will be complex. Now, when we started developing this framework, at least personally me, I had no idea how much effort does it take to maintain everything. In most cases, there will be a few people that will write the framework. It might be developers, it might be test engineers, it might be mixed, but in most cases, there will be a few people that do that. And after that, there will be a lot of people that will be writing automated tests. So the knowledge sharing between them is totally crucial. Because if you're not able to share the knowledge, then even the best frameworks can go totally unmanaged, and the end users will create their own implementations and stuff like that, and we don't want that. So what we did is, of course, documentation that you could read and get to know the framework, but we also applied code reviews here. That allows you to share not only the programming knowledge of how this was implemented and stuff like that, and maybe if someone's doing something wrong, you can actually tell him and lead to the correct way, but also the testing knowledge. Because as other testers are reviewing your code, they might say, this can be done better, this needs to be tested, or maybe this stuff is covered by unit tests and it simply can be avoided. And everyone makes human mistakes. Everyone's a human. From simple mistypes to complex issues that actually can cause the false positive tests. And all of this can be not totally avoided, of course, it's not possible, but the scope of the actual issues that goes to develop can be reduced dramatically. Now, like Vaidas was telling before, continuous integration is a very important process that most of the companies actually have right now or will have in a short period of time. And when you actually build your tests, when you have all of these tests done, the huge effort that was actually done, then it is, if no one believes in your system, if it's constantly failing, breaking, and belly up, no one will take it seriously. So if a developer runs automated tests in his feature branch and something fails, he will say, oh, it's just flaky. It wasn't me that broke it, it's just flakiness. And then you'll have to invest your time, go there and check if what's actually happening. And that is an issue that you waste your time. And we want to prevent that as much as possible. We want the response time to be as good as possible. So if everything is constantly green and suddenly something fails, there's only two options. There's an actual bug and you have to go and register and fix it, or something in the system changed and you need to modify your tests to comply with that. So the response times are a lot faster, and that is what we actually need. Now, the last maintenance tip that I would like to give is decoupling the tests as much as possible. Because if you're testing as little as possible in your tests and something goes wrong, you will surely know that this feature, this small component or something, is not working. If there is multiple items that you're interacting with, if there is multiple asserts in your tests, you will not be able to, you will get the result eventually when you're actually checking the logs, when you're, but in some cases there might be, if something fails in the tests at the top of the test, the rest of the code might not even be executed. So it will hide the issues. So if it is possible, always try decoupling and leaving these tests as small as possible. It's not always possible, but you should always try that, because maintainability is a huge part of your work, and if you want to keep it simple as possible. Then another tip, what actually helped us incredibly, was the navigation via URLs. Initially, we made it through UIs, and it was incredibly slow. And because of all this loading that you have to check that when you press something, it's loaded, then go deeper, you have to know that all of this, okay, when you're having this, you have to know, sorry, this got distracted. When you're using these navigations via UIs, you're wasting time, you're increasing flakiness. When we changed all of this to navigating via URLs, we managed to gain a lot more stable system and a lot better speeds there. That's what you want. Another big thing is setups and teardowns. In most cases, pretty much in any case, your framework will handle that, and there will be a lot of steps that will be done before and after the test is finished. And what you want to do is reduce the time it takes, and also you don't want to lose the stability. You want the UI interaction only in the tests and not in setups and teardowns. So what we did is moved everything to setup and teardowns via APIs. Now it's a lot faster, a lot more stable, and also APIs are in most cases covered by API tests. So that means that they're pretty much double proof, bulletproof, whatever. And that is what you want. You want to use for setups and teardowns, something that will not break your tests. So that was our framework, how we actually implemented the main pillars on which we built it. And the main tips and tricks from our mistakes and our implementations we learned. And now about the actual, how we work with it in everyday life will be Vaidas.
Thank you. Thank you, Paulius. And yeah, so about real life. How many of you uses Scrum model? Okay, so right audience for these slides. Doing test automation in the same sprint, automating the features at the same time when they are being developed. That is real, and to do that, you want to have test automation as part of definition of done. If some of you are not familiar with definition of done, it's basically, that's why I put the slide here, it's definition of done. Basically what it is, it's just a checklist, some set of rules, that stuff that needs to happen before you close any story in your sprint. It could be a feature, it could be defect fix, any deliverable that programmers do and pushes out during that sprint. So I will show the definition of done of our team. First it's code complete. Basically what you want to do is to complete the code before you close the task, right? That's quite obvious. So the next one, code reviews. As Paulius mentioned, and I was mentioning before, that very important thing, the very important part of development process is code reviews. The fellow developer with fresh eyes, he will see mistakes, he will notice things that other doesn't, and it's like a combined brains of all the engineers working on the same issue, and that will give incredibly better results than just working on your own. So code reviews is the next step in definition of done. The next one is manual testing. As I mentioned before, manual testing is undeniably the crucial thing in testing. Testers' experience will give you the confidence that the feature is ready. But that's not all of it. The last one that we have is automation test coverage. What that means is that every new feature, every defect fixed, every task that changes any code in the code base, before that task is closed, it has to have UI test automation coverage. And it works, it's possible, but I know it's not easy to get here. Because there are a lot of pushback if you try to introduce this. There's a lot of skeptics that will tell you it's not possible or it's not worth the time, stuff like that. We have arguments with skeptics. I have a slide that's called Myth of Auto Skeptics, and I will try to talk about some of these myths. And I will try to be fast with that. They say you have to finish code before automating. Well, you can do that, but also you can write the code in the same time as you automate it. You can even start from test automation before developers finish the code, and there are a lot of advantages in doing it that way. The next myth we have is that they say it's already covered in unit tests. Unit tests are important, they are the must, but unit tests is not enough for most of the features, like for all the features, because let me show you the slide. This is a collection of units, and each one of them is perfect. But it doesn't mean that they fit together well in complete software. So you have to have integration tests also to make sure that complete product works, not just single parts of it. And the next myth, the most popular, is they say we will deliver less in same time if we spend time on test automation. Well, it's actually quite true, but let me ask you this. How much do you want to deliver if it's that what you're delivering? I wouldn't recommend to save costs on product quality, and test automation is a crucial part of that. So that would be all from us today, and thank you very much for listening, and maybe you have some questions.